Hello everybody, my name is Slater Jones and I will be teaching you how to do a means, one sample, two sample confidence interval, and a means test, one sample. Right now I'm going to be teaching you how to do a means, one sample confidence interval. So, Milk's favorite cookie. For their second semester project in AP Statistics, Ann and Tori wanted to estimate the average weight of an Oreo cookie to determine if the average weight was less than advertised. They selected a random sample of 36 cookies and found the weight of each cookie in grams. The mean weight was 11.3921 grams with a standard deviation of 0.0817 grams. So the problem says construct and interpret a 95% confidence interval for the mean weight of an Oreo cookie. So first we see that it's a confidence interval because it says estimate. This is a key word we need to use here when we know we're trying to do a confidence interval. So the first thing you do is that you would find your parameter. And first you would find the parameter by looking at the equation. So first you would say that the parameter would be the actual average weight of an individual Oreo cookie. We got this answer from looking at the equation. Because of Ann and Tori selecting a random sample of 36 cookies, they want to see what the actual weight is of an Oreo cookie. So they just find the parameter, which is the original population, and this is what it would be. So next, you would find the conditions. First condition I see is the sample random. They selected a random sample of 36 cookies, so the sample is random. So the random condition is met. Next, you find the 10% condition, which you write 10% if if the population sample size is 10 times greater than the sample size, then we have our 10% condition met. So the sample size for the cookies is 36. So you do n is greater than or equal to 360. And so you get this number, and then you see in the population, you assume that there's going to be more than 360 cookies in the population. So that condition is met. So last condition, I would need to find the large counts. So and you do that by finding the sample size and see if it would be greater than 30, and which it is. So that's good. Large counts condition has been met. So next, you would find the description of the sample. You find this by knowing what type of sample we're talking about. So we're talking about means, so we would use T, and then the degree of freedom is n minus 1, which is the sample size minus 1. The sample size is 36, so we would get 35. Just do this, 36 minus 1. And then we find the standard deviation right here. With this, we don't know what this is, so we just put mu. And then for standard deviation, we put the standard deviation of the sample size up in here, and we get that by looking at the answer. It gave us 0.0817 grams, so 0.0817 grams. And then we put the sample size under a radical in the numerator, or the denominator, sorry. And then next, we work on our work. This is where we find the interpretive confidence interval. So here's the equation. It's mean plus or minus standard deviation of the sample over the radical of the sample size, and that's it. Or no, I forgot, include the t-score in here. So we get the mean from looking at the equation, 11.3921. So we just plug it in, 11.3921 plus or minus. And so you find the t-score from using your calculator by finding inverse t of 1 minus, and then you get this number from looking at the confidence interval. So we're using a 95% confidence interval, so we put 0.95 over 2, and then you find you look at the degree of freedom, and then you insert this in here as well, and so that would be 35. Now with that, you find it on your calculator. Hold on, I'm trying to get a calculator. So you go to second vars, you go to inverse t, and then you put it in. So this would equal 1 minus 0.95 over 2 would equal 0.025. So we put that in our calculator, 0.025, and then how do you put in the degree of freedom? Then you do comma 35, and then parentheses, and enter. Now we got negative 2.0301. We do not use the negative, we take out the negative. So that's 2.0301. So we plug that in here, 2.0301, and then you plug in the standard deviation of the sample and the sample size. So this is where we get our interval, and this would equal to 11 11.364, and then 11.42. So our conclusion would have to be, according to the equation, our conclusion would have to be is that we are 95% confident. We are 95% confident because we are using a 95% confidence interval for the mean weight. So we are 95% confident that the actual mean weight of an Oreo cookie is between 11.364 and 11.42. Thank you.